Hi everyone, in this video we're going to go over Leetcode find peak element question. Major tech companies like Amazon, Microsoft, etc. are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. A peak element is an element that is greater than its neighbors. Given an input array nums, where nums of y is not equal to nums of y plus 1, find a peak element and return its index. The array may contain multiple peaks. In that case, return the index to any of the peaks is fine. You may imagine that nums of minus 1 is equal to nums of n and is equal to minus infinity. So we are looking for peak element in an array, and a peak element is element that is greater than its neighbors. For example, in this case, 3 is greater than 1. 3 is greater than 2 as well, so we say 3 is a peak element here. Or in this one, 2 is greater than 1, and 6 is greater than 4 and 5. So we have two peaks here, 2 or 6. The array may contain multiple peaks. This part is important. In that case, return the index to any of the peaks is fine. Your solution should be in logarithmic complexity. To solve this problem, we can do a for loop, go through the array in an on time complexity, compare nums of y to nums of y plus 1, and find the difference and find the peak number. But that would be on time complexity, and the question says we should do it in a logarithmic time complexity. So in this case, we can use binary search to solve this problem for logarithmic to reach logarithmic time complexity. Let me show this in the whiteboard. In a logarithmic time complexity, for example, for binary search, I have one start point and one end point, and one middle point. I compare middle to middle plus 1, and if it's ascending, then I start looking this part of the interval, this part of the array. Because I'm looking for a local maximum, local peak, I will either look on this side or this side. If mid plus 1 is greater than mid, that means it should be on the right side. Then I put my mid plus 1 here, sorry, low here, and do another low and high divided by 2, and I find the peak number here. Again, compare with the right and left, right, and return the middle number here. This is how the peak looks. So I have two peaks here, and first I land the middle number here in the binary search, and I start looking right hand side and find the mid number, compare, and return the mid number. So that's pretty much what we need to do. In the examples, there are some good examples, so we can see how it works. For this one, in the binary search, this example shows how binary search works in the graphic. We can do like this. Find the mid first, then find which part we are looking for, find the mid again, we eliminate this side, and find the peak. Or this one, find the mid, eliminate the side, find the mid again, find the peak. Or this one, find the mid, eliminate this side, find the peak, and return the peak. This is a regular binary search. We create low, high, and the while loop for the low and high. For integer overflow, low plus high minus low divided by 2. And nums mid greater than nums mid plus 1. This is the if check that we need to do to move our high and low boundaries. We are checking mid to mid plus 1. Then create new local search area. And finally, return low. Okay, this works. This is pretty much it for finding peak element in logarithmic time. I hope you found this video tutorial useful, and I will record more videos soon, so if you subscribe to my channel, we'll meet again later. Thanks for watching. Goodbye.